Everyone, and thanks for your patience. I'm a commuter to Atlanta, and so the gods of the traffic found 3 wrecks to put in my way on the way up here. So feel sorry for those in the wrecks, but I'm glad to see such a good attendance this morning. And I want to thank our presenters today. This is part that we enjoy doing is this committee. I've named us the Geeks, and someone said I have to get better at a title for us. But anyway, we love learning new things, and so appreciate your coming here today. And so Representative Williams will open us with a prayer.
Thank you, Madam Chair. Let's pause for a moment of prayer. Kind and gracious God in heaven, Lord, as we come together, we give you thanks for the gift, Lord, of another day. And we recognize that every day, Lord, is a gift from you. As we come together, Lord, to discuss the bounties of the earth that you have provided us with and entrusted us with, we just ask, Lord, that everything that is said and done here today would be pleasing to you and in furtherance of your kingdom. Lord, lead, guide, and direct us. Be with us. Give us safe travels. In Jesus' name we pray. Amen.
Amen. Again, thank you for being here. And we have 2 presentations today. One has now been shortened to the Ray. This committee, I think it was 2 years ago, heard our first presentation on the amazing things being done for new efficiencies in electricity and just conservation, and we've got it right here in Georgia, and it's attracting international interest. So we're thrilled to have an update on that and to let the committee know we were the first audience for this new project. So it's fun to track it and see where we are. Then our second one will be on Nexus Fuels, and I named this our not our dumpster diving, but our landfill diving issue. So this is what we're keeping out of the landfill that used to have to go into the landfill. So we're pleased to hear about that as well. Now, Representative Randy Nix is our legislator from Troup County, and he will introduce our first presentation. Thank you, Representative Nix.
Thank you, Madam Chair. Well, it's a pleasure for me to be able to introduce the Ray, is what we'll call him for the time being, but several years ago, I was contacted and asked about doing a road naming for Ray Anderson, who, of course, was the founder of Interface Flooring. And I never knew that just that road naming would set into motion all of the things that have occurred since that time. It has now become the Ray from exit 2 to exit 18, really from the state line to exit 18. And they've done some very, very innovative things. They have a lot of more innovative things that they're working on. It's kind of hard for me to keep up with them, but I'm looking forward to hearing about it. Harriet Langford, who was Ray's daughter, and Allie Kelly, who has been involved with it from the very beginning. So I'm looking forward to hearing what I've missed just in the last 3 months since I've been up here. So it's good to have y'all here.
If y'all will come forward, and let's use the table in the front. Oh, you have a presentation too. So why don't you start with the presentation? Good morning.
Hi, I'm Harriet Langford, and I'm the president of the Ray. Out of curiosity, how many of you might have known Ray Anderson or heard about Ray Anderson? It's always nice to see somebody that knew him. Ray was a unique fellow. He was born and raised in West Point, Georgia. Came from very humble beginnings. His father was a postmaster, and his mother was a retired school teacher. And back in those days, when you began to have children, you came home and you raised them. So Ray was very fortunate to be a gifted athlete, and he ended up getting a scholarship in football to Georgia Tech, and that was really his only way for college. And he ended up doing really well at Georgia Tech. He began his work in Procter & Gamble and then moved to Milliken. And in the early 70s, he discovered what was called carpet tiles. And he was like, oh, we need this in the United States desperately. High-rises had begun to develop, and the flooring had really changed. Wiring began to appear in the flooring instead of the walls. So carpet tile made perfect sense to Ray. So he rolled the dice. He took all of his life savings with a 12-year-old daughter and a 16-year-old daughter that were going to be going to college. He said, I got to roll the dice. So he was very successful in really establishing Interface to be a global corporation. And he grew this business to be over $1 billion business. In the mid-90s was when we call the epiphany hit Ray Anderson. And he was totally convicted of being a plunderer. And he said, I've done nothing but take, make, and waste. And that's a high-intensive process of carpet tile, water-intensive, energy-intensive, and 80% petroleum. So Ray said, we've got to learn how to manage our product. How can we reclaim and reuse it? So he was the first industrialist to really think of recycling products. And today in the mainstream, you can look at Walmart and other big corporations that have followed exactly what Ray did. So we know he left a big impression on the world with his concept of recycling. And literally they're dumpster diving, landfill diving to get these products back in business, in circulation. Ray lost a battle to cancer in 2011. He definitely wasn't ready to go. But out of the kindness of his heart, he left the majority of his estate to a foundation. But he left no directions or instructions for his family. So we really had to find our way as to what we could do to really honor Ray and keep his name alive. So the first thing that we worked on was just getting the highway where he was born in West Point named for him, the Ray C. Anderson Memorial Highway. And this extends to exit 18 in LaGrange, where a facility of interface was there, and also another facility in West Point. So what happened and how did we get here today? After we had the highway named for Ray, I had this really true spear to my own chest. I had just put the greenest industrialist name on a dirty highway. And you say, dirty highway, what do you mean? Well, this is a asset that we've really never looked at, and we find there's a lot of value. If you look at an interstate system, it's been built the same way for 60 plus years. What if we could make this interstate different, more aesthetically pleasing? What if we could be looking around the world for technologies that could help reduce our carbon footprint on the highway? So we're looking very high, lofty goals of 0 deaths, 0 pollution. And this is a big job. But what we love about it is we went straight to Georgia Tech, College of Architecture, threw out this crazy idea, and we had Georgia Conservancy helping us with this project, and this is the blueprint for successful communities, but we said apply it to a highway. And what they ended up doing was applying exactly Ray's mission, his goals, his framework. We applied it exactly to the highway. So we've got this wonderful, robust, finished product. It was so broad, very global. We felt that we really needed to evaluate what technologies are available today and what will be coming in the future. So we're calling this actual highway a living laboratory. We were really fortunate to be able to work with Department of Transportation in Georgia. They signed a resolution to allow us to come play on their playground. But we're going to make this the safest highway in the world. The less carbon, the better. And if we can save lives and change our whole persona of what a highway really could be, we think we're onto something here. This could be globally recognized and applied anywhere. I'm going to introduce Allie Kelly, and she is our executive director of the Ray, and she'll finish out with what we're doing on the Ray.
Good morning, Madam Chair, members of the committee. Thank you so much for giving us an opportunity to address you today about the Ray. This is a project that has truly taken on a life of its own. As Harriet mentioned, when we first got started, we didn't know who we were, or what we were doing. Georgia Tech gave us some great direction in a very broad baseline study, but honestly, we needed to enlist some additional help to help us hone in on what we could do here in Georgia to look into the future 30 years of what our highways may look like and how they may function in the future, and try to bend that arc forward to bring the transportation infrastructure that we'll use in the future, to bring that to the here and now, so that we can begin planning for how that transportation infrastructure will function and how we'll fund it. the group of professionals who we worked with to help us create a feasibility study for the first 5 years and then beyond for the Ray is a technology firm called Innovia Technology. They're over in the UK. We were able to connect with them through Boeing. One of the board members of the Ray, who we have the pleasure and honor of working with, is the former chief engineer of Boeing who designed the Dreamliner with Innovia Technology. So the Ray, a nonprofit foundation in Georgia, is working with an international technology consultant to understand what opportunities we should pursue first, foremost, and then into the future for the Ray. Again, I want to emphasize for y'all, this is not a project where we have goals that we're going to meet in 5 years and then we're done. This is a nonprofit foundation that has been endowed in the last year that will continue to work far into the future to have a role in leading the way for this country and for the world and what future infrastructure should look like and how it could function. So let's talk a little bit about what we've done so far on the Ray itself. As Harriet mentioned, we have a really unique partnership with the DOT, with the State Transportation Board, and with the DOT Commissioner. For you to understand how this functions, Commissioner Russell McMurray has created an internal working group, and we meet regularly. About 24 staffers with DOT meet with the Ray, if not monthly, every other month, to understand what we want to achieve in that time period on the Ray. And when we get to some of the technologies that we've executed in the recent last couple of months, you'll understand how important the partnership is for achieving what we've been able to do. The first activity that we undertook was in 2015 with Kia. Kia's only North American manufacturing is on the Ray. And 2015 was still in the early times for the Ray, so we didn't have a specific idea of cutting edge technology that we wanted to implement, but we knew that there was no EV charging infrastructure on Interstate 85 coming into Georgia from the west, and we knew that that gap in EV charging infrastructure was preventing EV drivers from coming into Georgia from the west. So we partnered with Kia in West Point to install a fast charging EV charging station at the DOT Welcome Center, which is at the state line. That EV charging station will achieve at least an 85% charge in about 20 minutes, which is an appropriate time frame for someone who's visiting the visitor center for a comfort break, for travel information, for traffic awareness or what have you. And we've connected that EV charging station with a solar array. So we're using clean energy from the sun to power what is the cleanest transportation technology currently available for cars. And this is the first of this type of infrastructure in the Southeast. We refer to it informally as PV for EV, which stands for solar for EV charging. So this is a completely clean cycle of energy for EV charging. And that little solar array at the DOT facility has generated nearly 6,000 kilowatt hours of energy from the sun, and it's averted about 4.5 tons of CO2. And that's just a diagram of where it's located on the DOT facility site. Moving forward in 2016, once we had worked with Georgia Tech and Innovia Technology and understood that there are a lot of DOT transportation assets that are not fully leveraged, and if we more fully leveraged transportation assets, and specifically I mean the rights of way and the travel lane, if we could more fully leverage those assets, that may create more revenue for our transportation system, it might create more revenue and activity for our economy, and it might produce other benefits for our communities. One of the ideas that we shared with DOT and eventually also with the Public Service Commission and with Georgia Power was the idea of using portions of rights of way, which is the area on either side of the highway and the center median. Could we use that right of way for generating renewable energy from solar panels and or from wind turbines? What we achieved last year is approval from the PSC and from Georgia Power to build a megawatt of solar in the right-of-way of the Ray. This is going to be about 3,000 panels at exit 14, which is a Lagrange exit, which is, nearly in the middle of the Ray. This is going to take up about 5 acres of the interstate right-of-way, and it's going to require the use of an entire triangle of that interchange between the Ray and exit 14, the Whitesville Road, which is the interchange, or the bisecting road at that interchange. So where the road meets the interstate creates 4 quadrants or 4 triangles, and this megawatt of solar will take up one entire triangle of that interchange. This is a megawatt of solar that will be funded out of the 2016 IRP for Georgia Power, which means that it'll be funded out of their rate base, and therefore all of the power needs to be directed back to the grid. So all of the clean energy generated by this right-of-way solar pilot on the Ray will be to the benefit of all the ratepayers and the benefit of the grid. This will be the first solar project in the right-of-way in the state of Georgia, and only the 5th in the United States. This is being regarded as a best practice pilot for the country. This is the first right-of-way renewable generation pilot where a utility and the DOT have come together willingly to produce the pilot. So this is right now a best case example of how this can occur in other states, and it's happening right here in Georgia. In December, we took a step further in thinking about how transportation assets might be better leveraged for producing clean energy. And with our state DOT, we installed solar on the travel lane itself. This is a new product that has been developed out of France. The French national government worked with a private construction company called Colas for 5 years now to develop what is drivable or drive-over solar. They have several pilot areas in the country of France that they've operated over the last 5 years. When they decided they were ready to install a pilot outside of France, they came to Georgia. They came to the Ray. We actually informally competed with Google, with Apple, with Intel, with Arizona State University to host the world's first pilot of drivable solar, and the Ray ended up being the company's first choice. So if you want to take a look at the statistics, our pilot site is a small site. It's about 50 square meters. You can drive over it in any number or any variety of vehicles, a fully loaded 18-wheeler, a fully loaded tour bus, construction equipment. It is actually adhered to the existing roadway, so there's no need to change the road that you already have at your disposal. The company has a couple of patents. One of the patents is on the adhesive that binds the solar panel to the roadway. And then they also have a patent on the glass protective overlay that goes over the solar. The surface itself of the wattway, which is what the solar road is called, the surface itself is a safer driving surface than even new concrete and new asphalt that we pour here in Georgia. So it's very skid resistant, and it's got about the same durability as a new road, about 10 years worth of durability. The great thing about Wattway is that if you ever decided to uninstall the solar from the road, then you still have the longevity in the road that's underneath the Wattway, because the solar panels are basically armoring the road. I'm going to take a break and just ask if y'all have any questions. And I'll
Hold on just a second. So in this process, for our committee members, if you have any questions, just press your button, but be sure and give your name. So any questions here? Here we go. Okay, number 14. And okay.
Thank you, Madam Chair. Before I ask the presenter any questions, just out of point of reference to your earlier comments, I would prefer nerd and not geek. Geeks are known as not intelligent and non-athletic. Nerds are athletic and very smart. So
I'm thinking
okay?
redneck nerd is what I'm coming up with.
How about just a good old country boy?
All right, and good old country girls. We'll go together.
Representative Corbin and I are sitting here. I don't even really know where to begin. The Wattway just kind of set me back a little bit. I mean, you never know what you're going to hear and what new innovative ideas are out there, but the Wattway I mean, that's a whole new world. Just a couple of things. You said same life expectancy as a road today, 10 years.
Mm-hmm.
So when you go into, I mean, cost per mile, how do you restore your base and then go back? Are those tiles reusable once you take them up and put them down in the shoulders of the roads? How do you protect them for coming onto a highway off of I don't know, say a log truck coming out of the woods?
Yeah, so
Just a thought.
Yeah, so right now the cost of this product is not efficient. This is a really small pilot that we have on the Ray, so it's 50 square meters, so nothing is done at scale. Here's the other problem as far as cost is concerned. Because the French government was involved in this pilot, during the pilot phase, they have prescribed components, right? Which means that they require French companies provide the components. So not all of the components are the best in terms of their efficiency, and they're also not the cheapest, which is to say that when this product moves out of its pilot phase and those restrictions are loosened, we can use American solar panels that are more efficient at creating energy from the sun's rays and that are cheaper. We could, also use solar panels from other countries like China that are a lot cheaper than the panels that the pilot uses. So right now we don't have a cost efficiency with this pilot. What we attempt to do on the Ray, I like to talk about this in terms of baseball terminology. So there's a lot of innovation involving transportation that's occurring all over the world. A lot of it's happening in Europe, but not just in Europe. There's stuff happening in Peru, there's stuff happening in the Philippines, there's a lot of great innovation. And what the United States needs is a catcher. We need someone in the US who's able to say, that looks interesting, I'm gonna catch it, I'm gonna catch that idea, and I'm gonna work with some professionals to understand if it really performs well and if it's really ready for prime time. And if it's ready, I'm gonna put it in the ground in America, and we're going to see if these ideas can scale in an American market. And that's what the role that we've tried to step into on the Ray. In the beginning, Harriet and I and Representative Nix were like, let's beautify the highway, let's make it look nicer for Ray, and maybe let's put a solar panel as a public education awareness activity. And where we've come from that original thinking, we're still doing wildflowers and we're still doing solar panels, but our role has become something of a broader influencer. We desire and hope that we are a national and international force for influence of seeing what might be coming in transportation and actually using philanthropy, corporate, and public dollars to put it in the ground, to test it and to try to help it scale. And some of the things that we do on the Ray in the future, we'll come back to you and we'll say, it didn't scale like we thought it did. It didn't perform like we thought it did. But some of the things that we do, we really hope and believe have an opportunity to scale, and this is one of them.
Thank you, Madam Chair. May I follow up?
Yes, that's France calling.
I set a timer because I could keep y'all here.
Were you cutting me off? I'm sorry.
No, Representative Nimmer.
Madam Chair, another.
Yes, please.
So one, I didn't have the pleasure of raising my hand when you asked who knew Mr. Ray, and obviously that's at my loss for not of knowing him. But so when I sit here and I think about stuff like this, and really the sky's the limit, and just three things popped in my mind when I think this can't really happen: 3D printing, electric vehicles, touchscreen technology. I mean, so finding the efficiency. Well, do you know where the pilot will be constructed? You may have mentioned it.
So this pilot's in the ground. These are actual photos of the Wattway on the ground. So we can take a field trip to the Ray and we can see the wattway. These photos are actually from the Ray, so that's our
Okay.
50 square meter.
And I'm sorry if I missed
pilot.
that. I know you mentioned the triangle, that the 5 acre
Yeah.
area in the median that was being constructed. I didn't realize that was already
Yeah,
done.
the 5 acres of solar is going to likely break ground this year. And if I could just add, this is a low tech but an important postscript. We are trying to use pollinator habitat as the vegetative strategy for that solar array. And here's why that matters to you. We have a lot of solar, 50 megawatts, 100 megawatts, hundreds of acres of solar, utility scale big solar in South Georgia near farms. And if we move from using turf grass as a vegetative strategy on these solar arrays or gravel and instead use pollinator habitat, you're helping adjacent farmland because you're bringing butterflies and bees to the farmland, and the farmland needs that stuff. So I'm not here to tell you that butterflies and bees are high tech, but I do think Georgia.
I think they are.
I think Georgia needs to
I
move
think there's
toward.
a lot to learn from them. One more question, Madam
All
Chair, and
right.
I'll quit. I'm sorry.
That's fine.
If I understood the question you were asking, that my answer is yes.
Repeat the question.
If she wants to come down and take the Ray and invest in my area around some farmland,
Yeah.
the answer is yes. But no, thank you for your presentation and the work y'all are doing.
I'm almost done. May I have a few more minutes?
Yes, but we actually have 3 more questions right here. So
Okay.
I'll watch our clock for us.
Okay.
But this is a learning type meeting, not necessarily a legislative process. So my next number is 24.
Thank you, Madam Chair. Deborah Baysmore from District 63. Thank you so much for your presentation. I am all for using our natural resources to help us function. Just one question. On one of the slides, you had I think it was the 3,000 acres
Yes, ma'am.
and 170 homes. What did that refer to, the 170 homes?
That's the megawatt of solar that Georgia Power is installing in the DOT right-of-way. It's 3,000 solar panels on 5 acres, and we estimate that that will provide power for 170 homes,
Gotcha. Okay.
or the equivalent power.
Okay. Thank you for that.
Thank you. And now we have number 26.
Thank you, Madam Chair. Sherry Gilligan from District 24, up and coming, Georgia. And I'm very curious about the solar panels in the right-of-way and also the solar collectors that are on the roads, mainly because I'm very light sensitive, always have been.
Mm-hmm.
And I imagine that there are times where glare or glint would be very harsh. So I'm curious about that. And then the second question would be on the wattway, as cars drive over it, there is always some residue left behind.
Mm-hmm.
At what point do we start losing efficiencies because of that residue, and how do we treat those residues, and how, I'm sure in the pilot we'll figure this out, but do
Yes,
we
ma'am.
have an estimate on what kind of maintenance is going to require as opposed to a regular asphalt or concrete roadway?
Yes, ma'am. Those are great questions. With respect to glare, we've done a lot of research with DOT and with the utilities, and we understand that it is possible for concrete road material to produce more glare for drivers than solar panels. Nevertheless, Georgia Power is doing a glare study to understand how to best situate the panels in the right-of-way for our pilot. So we're taking the necessary precautions to make sure that glare is not an issue for drivers on the Ray. We would never want to compromise safety for any activity. Safety is DOT's #1 concern, and it is ours as well. Additionally, in terms of the inefficiencies of material building up on the road itself, with the solar road, the wattway, so we already have a reduction in efficiency because of the recycled glass overlay that's necessary to produce a friction surface and also to protect the solar panels. The buildup of residue on top of that glass overlay is not a huge concern for us because we get regular rainfall. So that residue would fall away from the road just like stormwater runoff, takes other pollution and other detritus from the road surface. In terms of maintenance, the company has developed the wattway in independent modules. So a failure in one module of the wattway would not bring down the entire unit or the entire length of that wattway. That being said, they have not had a failure in a module yet in 5 years of testing. Over 1 million cars or other vehicles traveling over their pilot sites in France, and they haven't had a single failure yet.
That's interesting.
Thank you. And then number 18.
Thank you, Madam Chair. I'm Buddy Harden from down in the southern part of the state,
Yes, sir.
Crisp County. You know, this, I was sitting here thinking, in Atlanta, I'm not sure solar panels are going to be too effective because the car is sitting on top of it all the time.
On the connector.
But the thing, I wonder, have you run any numbers to see how you would mix this with concrete, or would you wouldn't have, I don't guess, a total road of the solar panels, but what would be an effective thing? How often would you situate these panels, I guess?
Yes, sir. That would be a part of an overall strategy for understanding where it would make sense for solar to be deployed on the road surface, as well as solar or wind to be deployed in the right-of-way. You would want to couple that with an understanding of where you might have immediate demand for that energy. And where I'm going with that comment is if Harriet and I are looking 30 years down the road, here's what's happening. The technology is here today for us to charge electric vehicles while driving in a lane. Wireless charging, Harriet and I will actually meet with the British engineers who have done a feasibility study on this and are now buying assets for a real pilot in the UK. We're meeting with them on Friday afternoon. China is also investing in it's a wireless charging that's dynamic in a lane. And China is also investing about $60 million in a pilot in Hong Kong. And the Ray is very aggressive in chasing a pilot for the United States that shows that we can charge wirelessly in a lane while a car is traveling at highway speeds. And if we are able to stand up a pilot in the near future, we would need energy to feed into that lane because the energy in that lane would be transferred to wirelessly to an EV car battery. And so generating energy in the right-of-way via solar and wind and generating energy in the lane itself, capturing solar energy that falls on the lane and also capturing the kinetic energy that's created as tires and vehicles move over the lane, that energy can be pushed to strategic EV charging lanes where the charging can occur without you having to stop and connect your vehicle wirelessly or with wires.
Thank you very much.
Yes, sir.
There will not be a test when we're through.
If I can.
And do you have these slides to give us to?
Oh, yes, ma'am.
Okay, thank you.
I also want to let you know in December, because safety is very important to us, we installed the world's first automated tire tread depth monitor. It's a combined system. This is a technology developed in the UK. So we've worked with a French company and a UK company as recently as December. This station is a drive-through station. It's very similar to a McDonald's. You progress through it at no more than 10 miles per hour. It takes 7 seconds for all the tests and analysis to be completed. You pull up to a kiosk and you get a text message or a printed ticket that tells you the tire pressure of all of your tires, whether you have 2 tires or 18 tires. It tells you the tire pressure of all of your tires and the tread depth of your tires, how much tread remains on your tires. It gives you all of those analysis out automatically and instantaneously. It takes about 7 seconds. Again, this is the first pilot of this combined technology in the entire world. We have it on the Ray here in Georgia. Why did we do this? Because 40 people every year, at least 40 people in America die specifically because of tire blowouts and tire failure. And you may think that's not a very large number, but even one death due to a tire blowout because of worn tread is unacceptable. These are totally preventable issues that are causing really dangerous situations and deaths on our highways. Also, we're wasting about 2 billion gallons of fuel every year because because drivers' tires aren't properly inflated. So we can save fuel, we can save lives, and we can save on air pollution, because when your vehicle miles per gallon, when your fuel efficiency is not optimized, you're producing more air pollution at your tailpipe. So this is what the equipment looks like. You arrive at those 2 soft pads in the ground first, and there are 24 sensor pairs in each pad that fire about 530 readings per second to test and analyze your tire pressure. And as you roll over those pads, you approach the 2 center modules, which contain LED lights. Those LED lights illuminate the entire undercarriage of your car, and a camera system captures 360-degree views of your tires. And a nearby computer in a roadside cabinet runs an algorithm, and within 7 seconds you know your tire pressure and how much tread is left on your tires to 4 millimeters. This is the equipment on the Ray itself. This is free for the public, and this is used dozens and dozens of times a day. People come to the visitor center at DOT just to use this equipment. We also installed a tire inflator around the front, an air compressor around the front, because we didn't want people to get back on the Ray without correcting their issue. There's the kiosk that you approach. And there's your paper ticket. Kia helped us finance this demonstration in 2016, so Kia has been an important partner of the Ray for the last 2 years. I want to tell you that DOT permitted both of these. These Wattway had never been done in the U.S. before, had only ever been done in France. This had never been done in the world before, and DOT issued both technologies special encroachment permits. That's the kind of working relationship and the partnership that we have with the commissioner and the State Transportation Board and his staff. It's absolutely amazing what we have done and what we can do together in the future, not only to help to spur innovation and help to scale some of these technologies that are really impactful in our transportation system, but also to shine a light on the state of Georgia for our spirit of innovation, and to bring economic development to West Georgia and to the state as a whole. I'm going to just let you know that we've also, the foundation itself has invested $250,000 in beautification using native drought-tolerant plants. And then we've also worked with DOT to install a large pollinator garden, which was a first for DOT. And today, installation of a bioswale will begin on the Ray at Exit 6. A bioswale is just an area of native grass that's allowed to grow up over the course of the year. So it's a different mowing regimen for bioswales. They're allowed to grow tall so that they can do a better job of slowing down stormwater runoff so that it doesn't create as much erosion. And also the tall grasses help to filter out the antifreeze, the oil, the gas that accumulates on the surface of the road. It keeps those pollutants in the grasses before they reach the watershed. Last but not least, what are we doing this year and moving forward? We've had a brainstorming session with DOT about what we can do with drones on the Ray. We believe that we'll work with DOT and Georgia Tech this year to fly a couple of discrete drone missions for specific purposes related to safety or related to the ecology of the Ray this year. We're also working with leaders in DOT, with state leaders to try to incorporate more recycled tires into the pavement. Many of you may not know that scrap tires can go directly into the asphalt binder in place of petroleum. It actually makes the asphalt last 20 to 30% longer, and it creates a more safe driving surface during inclement rainy weather because roads that incorporate scrap tires in the asphalt binder handle water differently and you have less splashback. So there's a resurfacing on the Ray, a complete resurfacing of all 18 miles in about 18 months, and we are working with Representative Nix and others to try to make sure that when the Ray is resurfaced, that we pave it with scrap tires. Last but not least, we think we're going to stand up a wind generation pilot on the Ray using some new wind turbine technology that activates at about 2.5 mile per hour wind speeds. Georgia has not been a hotbed for wind generation because we don't even have, 8 or 10 miles per hour of reliable wind speed. But a cutting edge turbine that could activate at 2 or 3 miles per hour would be well suited for Georgia, particularly on a highway where you have fast moving traffic that creates its own wind system. If we are able to create a pilot of wind generation in the right of way, it would be the first in the nation. The last thing I'll mention is that the Ray is actually creating new technology that's safety oriented. We've applied for patents and we've actually prototyped the equipment. All I can say at this point is that we'll be coming back to you soon with physical prototypes to show you of instruments that we can add to the road itself that will allow the road to communicate dangerous conditions visually to drivers who are driving what's now called classic cars, which are really non-autonomous cars. But the piece of new technology that we're developing and building out of the Ray would also allow autonomous vehicles to connect to the road itself to receive additional information to keep us all safer on the roads. As Harriet mentioned, our goals at the Ray are really simple. We want to show that the technology is already here for us to be safer, for us to be cleaner, and for us to better leverage the transportation assets that we're investing in. We welcome all of you to come to the Ray to experience what we've done so far and hope that you understand that we're only just getting started. And we hope that the Ray will become something that the state becomes more and more proud of, because we're just trying to leverage and honor Ray Anderson's legacy in our transportation assets and our transportation system. Thank you.
So, thank you so much for your presentation. Will y'all be available after our meetings for more interaction?
Yes, ma'am.
All right. Thank you very much. Y'all, let's give them a round of applause. So our next presenter is Mr. Gold, Jeff Gold, and I'm not sure how y'all are set up to work, but Michael, will you be presenting as well? Okay.
Well, I actually didn't plan any formal presentation. I thought it'd be more important for you all. And sorry, Madam Chair, thank you, Michael Power with the Georgia Chemistry Council. Sorry, I just jumped right into it. But we thought it'd be better for Jeff, who has technology here in Atlanta, to give you guys a presentation about what plastics to fuel is. So, I represent the American Chemistry Council as well as the Georgia Chemistry Council, and we have a number of members that make a variety of plastic products from chemical compounds, natural gas, and oil-based international. And so we feel that this technology is an innovation that provides another alternative use for our products at the end of life. Obviously, the more higher beneficial use in the hierarchy of recovered materials is recycling. There's more value there, but there is a number of materials that after they are sorted at a landfill are too dirty for recycling and after they're sorted at a MRF, end up in a landfill. In Georgia, we estimate about 1.3 million tons annually of post-use plastics go into the landfill that are too dirty for recycling, and that's where technologies like Mr. Gold's will come in to help partner with those waste management republics of the world to collect that material and process it in a technology that actually occurs. The technology itself occurs in the absence of oxygen, either using pyrolysis or gasification, which he's the expert. I'll let him explain those things. But it's able to heat up or a chemical reaction to convert waste plastics back into oil. About 80% of what we take in can go into an oil product. 10% is captured in methane or propane gases, which many of our companies will use to power their facilities in the generator. So they'll need some electricity to get started, but once they're running and operating, they can use their own processes to run the facility. The last part generally is a char product that we are studying right now with EPA in one of the national laboratories to see what the BTU value of that product is, to see if it's worth burning as an energy production source, but we also want to make sure that the emissions are less than coal and things of that nature that are already being used. So I'll stop talking there and let Jeff sort of walk you through the presentation here, what Nexus Fuels
Since
is
it's
about.
not a actually day that the House convenes, we can go over a little bit past our 9 o'clock time. So
Okay.
catch your breath
All right.
and
Well, I'll let him
take your
go.
time explaining. So
right.
thank you.
Was there any
And
questions?
Mr. Gold.
Michael's pretty much covered it, so. Well, Madam Chairman, again, thank you, and committee, appreciate the time and the interest here. My name is Jeff Gold. I'm the CEO of Nexus Fuels, and while this is sort of a new thing right now that's emerging, we've been working on this about 6 years now, and we've been running a pilot plant right here in Atlanta, probably about 20 minutes from this location, up on Marietta Boulevard. And in that time, we've produced about 5,000 gallons of fuel, but more importantly, we've done a lot of research and experimentation to determine how to make this technology work. This is not a new technology. It's been around for many, many years. It started in the 60s. A lot of work was done in Europe exploring this, and unfortunately, fuel prices and the price of other hydrocarbon products that you get from this process were sufficiently low as to kind of stifle the development of this. With the rise in oil prices that we saw a few years back and continuing on to today, it has made this technology a bit more viable. There have been other attempts in this country to bring this to the forefront and actually make it useful. Unfortunately, for various reasons, those have not done particularly well. Is also another reason why you may have not heard of us until now. We are very results and very science-oriented. We don't want to go out and have a press release. We don't want to tell people how great we are and what we're doing until we are actually doing it. As I said, we've had the pilot run very, very successfully. As a result of that, we received some generous investment funding, and we're now commercializing the technology. It's over in the Fulton Industrial Area, is where our commercial plant is currently being built. So with that, I'll just try to move through this a little bit. You probably can't see that too well, but basically this is saying is, how this all kind of came about and what inspired the idea to do this is that, in the 1950s, plastics, started their thing, and everyone was like, oh my God, this stuff is great. It lasts forever. Back here now, today, you got the guy holding up the beer can thing, and he's saying, oh my God, this stuff lasts forever. It's horrible. So, the same sentiment, just a very different context. And where we see it here not only in Georgia, in Atlanta, everywhere on the beaches, in the Caribbean, in the Greek Isles, in Madagascar, you see the same thing. Plastic bags, flip-flops, plastic bottles. It's a scourge on the face, just from an aesthetic standpoint. But more importantly, you guys, I'm sure, are all aware of the problems it causes with sea life in terms of ingestion of this material. Whales have washed up, died because and they've ingested so much plastic in their system that it cannot excrete and expel that it causes them to die, and it's an increasing problem. We have a lot of material, so we have a lot of plastic that is produced. We consume that's a little bit out of date now, about 300 million tons of plastic per year is consumed worldwide. We recycle here in the United States about 40 million tons, and we landfill about 32 million tons. Actually, it's a little more than that now. We burn some of that in waste-to-energy recovery systems. That's considered kind of a dirty approach, while plastics is a viable fuel for this kind of thing, and it provides a lot of calories. It does produce some air pollution. It does produce some chemicals that are very undesirable, things like dioxins and dibenzofurans that are causing some problems from an environmental standpoint. A very, very small amount of that is 2.8 million tons is recycled. And that is largely the plastic water bottles. It's called PET, or that's a #1 plastic, it's called. And then the HDPE, high density polyethylene. Again, there won't be a test after this either, but it's There's high density and there's low density. High density are your shampoo bottles, your Tide detergent bottles, things like that. Those are very high value plastics, and they get pulled out of the recycle stream. So you got your water bottles, you got your HDPE, and the rest is kind of like, well, if we have a market, sure, we'll sell it. But most of the time, that isn't what happens. And that's where this technology is going to come in. A couple things, just a couple statistics here. Americans discard about 35 billion, with a B, water bottles each year. 1 million plastic bags are used and discarded every minute. That's worldwide. And they have a life expectancy of about 1,000 years. And a useful life, this is the kicker, the useful life of about 15 minutes. If you think about, you pick it up at the grocery store, you put it in your car, you drive home, you empty it out, it's about 15 minutes average. What do you do with it after that? Maybe some people reuse them. You can reuse them for holding trash and things like that. Most of the time, not so. 15-minute lifespan, 1,000-year life expectancy, 1 million a minute. It's a problem. So how does this play into a solution? Well, there's many ways to handle this that we've talked about. Burning it, landfilling really, we don't consider that too much of a good solution. So what we have taken the approach of is using a process called depolymerization. This goes back to high school chemistry, but polymers are what make plastics plastics. They're links of molecules in long chains that's what plastic is, all its various forms, that's how it works. And the way we deal with that is we simply heat these polymers. We heat the plastic. And in the process of doing that, it basically breaks those polymers apart and takes a giant chain and makes it into many smaller chains. Now, when those smaller chains kind of come back together and condense back into a liquid, we do this at a very high temperature, makes it into vapor. When it condenses back into a liquid, lo and behold, you have oil, various forms of oil. And it contains a wide range of molecule sizes, everything from pentane, propane, butane, that's the small end, to icosahexane, and a number of other high carbon chains that form wax, diesel fuel, heating oil, jet fuel, kerosene, gasoline. We make all those products from this process. So Michael had touched on this, and it's difficult to see there, but from that simple process, we get a number of useful products. Number one, we get gas, as I mentioned, propane and butane. We recapture that gas as part of our process, and it's probably anywhere from 7 to 10% of the weight is converted into these lighter compounds. We capture that and run it back through our system to provide the heat energy that is needed to drive the whole process forward. So it's a circular loop. Once the process gets started, it self-sustains. So our energy use drops off almost completely, and it self-sustains. The second and majority of the product that we're after here are the liquid products. And that, as I mentioned, is everything from gasoline, kerosene, diesel, heavy diesel, heating oil. Those all come out in various forms. A majority of the product that we get from our process is in the kerosene range. That's a majority of what we use. We don't use what's known as a catalyst to direct the product into one direction or one product or another. So we have a fairly wide spectrum of products. The other thing we get is wax. Now, wax is an extremely desirable product from our standpoint that can be used for a huge number of things. What do you think of when you think of wax? You think of candles. Well, that is certainly a product that we make. It's difficult to see in this picture here, but we've actually made a number of candles and distributed them. We have one that's a brewery that buys them, and we take their bottles, we recycle their bottles and make candle holders with them, put our recycled wax in it, and they sell them in their brewery. We also have distributed them to other people, to our investors in particular. And we've distributed them to some schools and for kids to learn about this process. And they've been very, very well received. They're extremely clean burning. We can put various aromas and scents in them, and it makes it a very nice product. Lastly, and Michael also touched on this, is we create a char product. The product that we take in is not clean in general, and not clean because it's got spaghetti sauce, it's got egg residue on it, it's got glass in it, it's got sand, it's got dirt, it's got all kinds of different things in it. But what we also have is a lot of paper. Now, when you heat paper at these temperatures, you get a carbon product, a char product. Well, you'd say that's not desirable, but in fact, it actually is. So every piece of the plastic and the residue that goes into this system comes out as some form of useful product. Some have more value than others, but every part of the carcass, if you want, gets used. We do not generate a waste product. We do not have air emissions. We don't have water emissions or water effluent. We don't produce any off product. Everything goes off as a product. The plastics that we use on this, we cannot take everything. We don't want the water bottles. Those are not helpful to the system. They don't make oil when you heat them through this process. We don't want PVC, the pipes, the white pipes you use in your house. And we don't generally want things like cell phone cases or computer cases or things like that, acrylic materials. What we're after is number 2s, number 4, number 5, and number 6. Those are the plastics we want. But that includes your plastic bags. It includes toys, a lot of plastic toys. It includes styrofoam. Those are all very desirable products for us to use. Styrofoam, when it converts through this process, actually is a very nice octane enhancer for the gasoline product. And this just shows, some of the ways it comes in. It comes in bales from recycling facilities. It comes in bags from industrial and commercial users. It comes in all sorts of forms. What we don't want is there on the right-hand side. That's your bottles, your computer cases, and your PVC. That sort of covers the range of products that we are not particularly interested in. So we have a lot of contaminants. I just mentioned paper, cardboard, PVC, metal. We have wire in there. Water is another contaminant. This stuff gets left out in the rain, gets a lot of moisture in it. Soil, garbage gets in there. So what does that make? Well, it makes char. That char we use as a asphalt additive. You mentioned that you use tires in asphalt. This is also an extender and an enhancer for asphalt. Also, the cement kilns use it as a fuel product. It actually is carbon black, if you're familiar with it. It's not stuff you want to get on you, for sure. It's really nasty. But it's a great high-calorie, pure carbon fuel. This is just a shot from our pilot plant. That's some of the oil we produce. It is not black. Beverly Hillbillies used to see, well, those of us are that old. Beverly Hillbillies, the opening sequence would always show Jed shooting into the ground, and up from the ground come a bubbling crude, and it was always black, and that's really what crude oil looks like. Our crude oil has sort of a limeade kind of appearance to it. It's very light. It's very bright in color. It has very, very little, if any, asphalts in it. It has no sulfur in it. It has none of the typical pollutants that come out of the ground when you get crude oil out of the ground. And from 1 ton of plastic, we are able to squeeze out and derive up to 270 gallons of oil. So 1 ton to 270 gallons. That's a basic little schematic of our process. That's, we put this stuff in and it converts. And again, we recycle the gases, we recycle the char so that every part is used. It's a highly automated process. So this will create jobs here in Georgia. And as we grow, it'll create more and more jobs. These are people that are at the site that are working to unload trucks. They'll be taking chemical samples. They'll be doing chemical analysis. They'll be doing quality assurance. And so they're not low-tech jobs. They're not super high-tech jobs. It's a good entry point for a lot of people in terms of a ability to enter that workforce. That's a picture of the pilot plant as it sits now. It is currently not running because we have used it for everything. It was designed to operate for 6 months. We ran it for almost 6 years. And we are now, as I said, we are commercializing. The picture on the middle upper portion there, it shows some blue flame. Those are the heaters that were configured under the pilot reactor there. That is gas that is derived exclusively from the breakdown of the plastic. It would run on that, and it looks like natural gas when you run it, but it's a mix of propane and butane. That's a conceptual form of the full-scale plant. Our plant looks slightly different from that, but it is a relatively small footprint. It will process 50 tons of recycled material per day, waste feedstock. Now, this feedstock right now, this is coming from a couple sources. The primary source is a location about 2 miles away from us, where it is a recycling facility for a number of municipalities, including Atlanta. So when you put your plastics out in your curbside box and they get picked up, this is one of the facilities where it goes to. The paper gets sorted out. Generally, the cardboard tries to get taken out. But what you're left with at the end of the line is a mix of material that is not valuable currently in the recycling market. And is in the current way that oil prices are going, it's not likely they will obtain too much value. China, who used to import a huge amount of plastics, has cut back dramatically on that. So what that's left the United States with is a glut of plastics with no home, no value, and nowhere to go but the landfill. So really what this is a waste management technology that, oh, by the way, produces oil, produces wax, and other products. So really it's a method, as Michael said, it diverts materials from landfills where you're paying to landfill them. It's taking up valuable land, it's taking up space, and it's not solving any sort of pollution problem and converting that into a product that can be used. Now, unlike PV and things like that, it will still, when you burn it, when you still use it, it will create, non-desirable emission products. But we're faced with kind of a choice here. We can take a product and stick it in the ground where it'll be for many generations, or we can try to make something useful with it, I guess I should say. One last thing here on this is that what makes our process different than others that have come before us? Well, the reason we proceeded with this whole plan, we took it from a bench scale test to a pilot scale test and now to a commercial line, only after we could prove to ourselves and prove to a number of third parties that we could do this efficiently. The whole premise of this technology is to make it efficient. If you can't do that, you're not going to succeed. What we have found is our efficiency, our energy return over our energy invested is 30 to 40 to 1. So for every kilowatt, every BTU, every joule of energy that we put in, we get 30 to 40 out. Compare that to ethanol, which is 1.3. For every kilowatt you put into ethanol production, you get 1.3 out, not much. Other people that have tried this before get about a 5. So we are about 6 times higher than any of the people that have gone before us. And because of that one fact, we feel as though we can be successful here. Starting in Georgia, starting in Atlanta, Fulton County is where this is going to happen. We've been working with the city of Atlanta on a number of initiatives. We're working with a couple large plastics manufacturers that are going to bring a special program, most likely to Atlanta, that will selectively remove useful plastics for our process that are not useful in the recycling, or not going to be used in the recycling industry, and selectively pull them out so that we can take that right at the source, make it much more efficient on the collection end and the sorting end. that'll help the city, it'll help the state, and it'll certainly bring a lot of attention, just as the Ray will. It's cutting edge, forefront technology, not only for the state, but for the country as a whole. So, and we feel we can do the same thing. I think we've covered the benefits, and then, any questions?
Mr. Gold, it's very impressive. Now is the time for questions, and we'll start off, just push your button, but again, say your name and ask your question. Number 14.
Thank you, Madam Chair. Chad Nimmer, District 178, and thank you for your presentation. Just a couple of questions, Madam Chair, if I may.
Yeah.
I noticed at the beginning of your presentation you mentioned that many of us may not have heard of Nexus due to various challenges y'all are facing. Are those mainly regulatory challenges or market? And if I'm asking you the wrong question, just tell me.
No, it's a very
You'll
good
see me
question.
offline. I'm just, when we start talking about using 1 million plastic bags per minute every day, and I think I jotted down 300 million tons of plastics per year, and we're trying to find somewhere to put those besides in my backyard and in the rivers I enjoy and the streams. And when my wife goes to the Caribbean and she sees an IGA bag floating down there from Blackshear, Georgia.
Yep.
I'm kind of curious why we're not. What are the hurdles you have?
The hurdles have been economic. Technical, economic. As I said, in the past, people tried to do this, but their technologies were very inefficient. And as soon as oil prices drop down, they're not viable. So you've got to have a process that can stand on its own without subsidies, without grants. It's got to be able to produce this product at market rates. You know, we are not relying on that. So the hurdle there has simply been finding an efficient enough technology that can stand on its own and be economically viable. So that's it. From a regulatory standpoint, one of the things we're pushing for here, and what Michael is working towards, is to make Georgia a friendlier regulatory environment for bringing this kind of technology here. Now, not that we want to see competitors, but it's needed, and there is more than enough to go around. There is, as you said, there is a lot of plastic. Yeah. And there is more than enough for more than one firm to deal with this.
So, Madam Chair, so if it's market driven, and I totally get, and I respect that you want a product that is a standalone and it meets all economic driving forces out there, and you don't want grants and subsidies, but this is one that may require it. And there may need to be some subsidies and some incentives put together to capture a waste product that's got a 1,000-year lifespan.
Yep.
To get it off our streets and our out of our streams and
we would
rivers.
certainly accept that, but right now we have our offtake agreements in place, we have our feedstock agreements in place, and we have every expectation of being profitable as soon as we start. So yeah, we've it's an obsession of ours.
So one more, Madam Chair, and I'm done. I promise. I know it's in the morning still. So a fair campaign to use more paper would be adequate. Is that right?
You guys are better.
We've got an abundance of natural resources called our forest in Georgia.
That's
We're number
correct.
one in the nation.
That's correct.
And if we use those adequately and promote paper bags, we could lessen that 1 million per minute usage on the plastic bag. Is that right?
If you want to, that enters into a whole different discussion. As it turns out, paper bags are less environmentally friendly than the plastic. As much as I hate to say
take that off the record. Strike that from the record totally.
If you look at the life cycle cost of that, that's what you get into it. It's the production cost, it's the energy cost, it's the transportation cost. The beauty of this kind of plant is this can be put anywhere. You don't have to be on a Gulf Coast, you don't have to be on a river, you don't have to be next to an oil field. You can be at any place, like an urban center that creates a lot of plastic. So you put these strategically in cities where the need is, and that's how it works. So the energy to bring, as I said, our feedstock source is 2 miles away. So our cost to bring it there, the environmental cost to bring it there, as far as the trucks and the pollution they will cause, is minimal compared to, unfortunately, paper products.
I'd respectfully disagree, and we'll have a different conversation about the paper and its natural benefit and impact. But however, I do wish you and Nexus the best of luck, because I know regardless of how much we promote our natural products, plastics are going to be a driving force in this economy and marketing and the way things are sold. And I do hope that you can find a feasibly sound way to use this product and market what you make.
I appreciate the sentiment. Thank you.
Thank you. And we have one more question. Okay. Or did you want to add something?
I just wanted to follow up on the original question.
Okay.
Thank you, Madam Chair. On the question of what we may need in the future, I do want to say we do have a good relationship with EPD, and they are working well with Nexus on the permitting of their facility here. One thing we see on the broader horizon for other companies that aren't located in Georgia already is that we sort of, as Jeff touched on, we compete. Oil being low sort of helps or sort of harms our ability to compete in a marketplace. Also, plastics are a commodity-based product, and so that price fluctuates over time depending on what the oil price is. And so one thing that we do see, and that maybe we would like to discuss with this committee and continue to have the discussions with EPD down the road, is some sort of permanent regulatory path for these companies, so that when we have two of our areas that are sort of fluctuating, we have one key area in the regulation process that's a little bit permanent. So, but I mean, the relationship with EP is great, or EPD, sorry, I'm thinking Florida right now a little bit. But
I hope that we can find a way for y'all to be economically sound without waiting on crude oil prices to go back up. And just to the same regard of a lot of South Texas towns are drying up when gas dropped below $3.50 a gallon, and that's unfortunate. Our consumption doesn't change much, just the way they refine and pump out. So I'm hoping that you guys can be innovative enough to find a way to make Nexus take off and go. I mean, you ran a 6-month template plant for 6 years, so obviously there's a need there, and I'm hoping that you can find that without crude oil going up.
yes, sir. Thank you for the questions.
Yeah.
Thank you. And then number 25.
Thank you, Madam Chair. Chad, if you stuck out
Randy
in the woods,
Nix,
you'd
Representative
definitely
Nix.
Randy Nix from District 69. If you stuck out in the woods, you'd much rather have the paper than the plastic, I'm sure. And I think that's what you
all
had
right.
in mind. Yeah.
Now we're nerds with humor, so that's pretty good. So.
You remember the old paper versus plastic commercial.
Right.
But the question I had is the sorting of this. I'm very meticulous about trying. I live in the county, and I have to take mine in. I'm very meticulous about getting all that plastic in the same thing. But I've got water bottles, drink bottles, the plastic that the detergent comes in and all. Mm-hmm. It is a big part of this, the sorting of the product. Is there any way to do that other than by hand? How do you sort that to make sure you got the right stuff?
It's a great question. Well, as I said, the facility that we're going to be drawing a majority of our material from now is just set up a whole new sorting line. Sorting is everything in your recycle business, because if you can sort out high-value products, you get more for it. So what they've put in now is they're moving away from hand sorting, and they're moving to an optical sorting. So there are these machines that are unbelievably impressive. And it goes through and it uses various wavelengths of light to detect different plastics. Then it has little air jets that shoot that bottle over here and that piece of plastic over here. Wow. It's incredible to see. And their yields and their quality is skyrocketed. Now, that is a cutting edge technology still. So most of the time it is hand sorted and very imperfect. People like you are fantastic because you are doing a lot of that hard work up front. I mean, what goes into the recycle bin, I don't even want to say it in this company because it's disgusting. It's like, you get potato. Well, I'll say it anyway. You get potatoes, you get diapers, and people put these in the recycle bin thinking, we call those aspirational recyclers. Like, well, gee, I hope they can recycle this. They put shoes and clothes, and it's like, no, we don't want that. And so people like you that do the conscientious sorting, the biggest thing you can do is take the glass out. Glass destroys recycling lines, and it does not get recycled unless it is pre-sorted like you're doing. If you sort it by color, then it can be reused. If it doesn't, it just creates huge mountains of shattered glass that grind up your equipment, and quite frankly, we're going to be seeing it. And half of our process is geared towards dealing with that problem of glass.
One other question, please. should I be putting the styrofoam in the plastic? Is that considered part of the plastic recycling?
From our standpoint, yes. Now, I don't believe most recycling facilities want it. In fact, you will get directions from your county recycling board not to put it in there. So what are you supposed to do with it? Okay, you're going to put it in your trash, right? When
Yeah.
you don't want it in the recycle bin, you're going to put it in your trash. What else are you going to do with it? You're not going to start storing it in your house. So that's the problem. We hope to change that. We want to say, yes, now we can take the styrofoam products.
Okay.
And there's efforts underway. DART company is doing a lot on their end to try to get that changed. Setting up collection centers and setting up recycling capability for it. So we hope to be part of that as well.
Fascinating. Thank you.
Thank you, Madam Chair. Debbie Buckner. Seeing Mr. Cowan out there made me think about landfills and how we could divert an awful lot of trash if it went through this process from our landfills and not have to cite anymore in Georgia. No offense. I don't look at you as a landfill, but I think I just made it worse, didn't I? But my question is, I'm assuming that since this project, that you were taking whatever feedstock that you could receive, but in a business plan, would your feedstock to, like, I'm looking down the road at cities trying to figure out a way to get that trash used in a different way. Would do you charge for the feedstock? Do you take it free if a city were to bring it to you, or do you pay for it? How would that work?
How would you like it to work?
I got you.
We pay for it.
You do.
Previous models, that's another reason they were not successful, is they wanted to go ahead and charge a tipping fee, just like a landfill would. Well, you know, it's just more effort. Who's going to do that? Nobody. We do have some people, some commercial groups that will give it to us because they have some things that they are happy not to have to transport it and pay tipping fees. But currently, right now, we actually have a model where we are paying a few cents a pound for this product. Yeah. So the suppliers can actually make money on their end. You know, what used to be a cost is now a revenue stream. So
Great.
it's a very positive. It generates a lot of impetus and a lot of energy to pursue that.
Thank you.
Thank you. As you see, we have a lot of questions and probably even more questions. So if you'll stay around afterwards to answer some of those, and committee members, check your folders. But I want to thank both of our presenters for bringing us up to date on this. It's really very fascinating. And the word plastics, I first heard it in the graduate as a money source. I have to confess to that. Plastics is, yes, plastics. So thank you very much for that. And I think a lot of our committee members are interested in tracking what you're doing. So if you'll give us a way to stay in contact too.
Certainly.
Really appreciate it. Thank y'all. And be on the, I think we have a committee meeting now scheduled for tomorrow at 3. Upon adjournment at 1 o'clock. So we'll send the notice out for that. There's a resolution or two to look at for that. And check your folders, and we'll stay. If y'all stay after, we'll enjoy talking to you. Thank you very much. We're adjourned.